Slope-intercept form you learned in Algebra 1 last year. In class, we did a little game of marble slides just to remind you where the slope appeared in slope-intercept form and what B represented. So standard form is here. Standard form is where A is a positive integer, so that should be a positive number at A, and B and C are also integers. Integers meaning positive or negative whole numbers, so no fractions or decimals at B and C when it's in standard form. So the next thing we went over were intercepts of a line. An x-intercept is where the graph crosses the x-axis. So it's going to be a number comma 0, because if you think about it, every point on the x-axis has a y-coordinate of 0. That's in common. If you go all the way across the x-axis, every time you pick a point, it'll have a y-coordinate of 0. The reverse happens with a y-intercept. It's where it crosses the y-axis, and therefore the x value of the coordinate is always 0. You're not going left or right at all. You're only going up and down on the y-axis. So in number 1 and number 2, your job is to find the x and y intercepts. So I'd like you to push pause now, use those definitions that we gave above, and try to find the x and y intercepts. So please push pause now and try to work through that. All right, moving to the answers. There's a couple different ways to do it, but this is a very pure way. To get the y-intercept, that is when the x value is 0. So I plugged in 0, telling the equation when x is 0, what will the resulting y value be? It's 3. I do want the intercepts written as coordinates. I don't want you writing y equals 3. That's not a y-intercept. That's actually an equation of a line. So you need to write it as 0, 3. Then to find the x-intercept, again, in the equation, if the y value is 0, what is the resulting x value? And again, I will be a stickler on the quiz. I want it written as a coordinate pair. I will not accept x equals 4, y equals 3. That sounds like a totally separate point, not even on the line. Again, in number 2, I plugged in the zeros and I solved, and my answers are 0, 4, and 2, 0. In the next slide, just some practice in graphing. The first one is in that slope-intercept form. So your slope is your slope is 1/2, your y-intercept is 3. This is in standard form. Standard form doesn't give you a lot of information, so change it into slope-intercept form. Okay, use your algebra skills to change it into this, and then you'll be able to graph pretty easily. So I'm going to ask you to please push pause and graph these two equations now. All right, these are your answers. I know they're a little off. It's a little difficult for me to do on the computer. So you're going to plot a point at 0, 3. That's my y-intercept. You're going to rise 1 and run 2. You also could have gone -1, and then as long as you went -2. I know that's not hitting that exact point, but it should. In the bottom one, I used algebra to transform it into slope-intercept form. Now I know my slope is -2 and my y-intercept is -1. So you should plot it at -1 and go down to right 1. Remember, this is a negative slope, so it should be decreasing. Just a little reminder for you on that. All right, the next one, find the slope and y-intercept of each line. So they're in different forms. So again, I'd like you to push pause, try your best, then come back and check your answers. So put some thought into it first. If you make an error, it's no big deal. I'll talk you through it, but at least you put thought into it first. So push pause now. All right, these are your answers. For this one, I couldn't really find the slope or y-intercept in standard form, so I transformed it into slope-intercept form. I found the slope was 2/3 and the y-intercept was -2. This one is already in slope-intercept form, so I knew the slope and I knew the y-intercept. The ones down here can be tricky. What this equation is saying is, I know you're looking at it and going, but it doesn't have an x. Well, what that means is x can be anything. There's no limit on x. X can be anything, but your y-coordinate must be -3. Every single time, every point on this line has a y-coordinate of -3, and x, they're not even going to mention because it could be whatever you want. So I just put some sample points down here where the y-coordinate was always -3. If you graph those, you'll see it is a horizontal line, so your slope is 0 and your y-intercept is 0, -3. In x equals 4, it's the same idea. All the points on this line have an x-coordinate of 4. I know there's not a y in this equation, so that gets confusing, but it's because y can be anything. It's describing all the points where the x value is 4. So again, I put some samples here. If you graph that, you'll find the slope is undefined, and since it is parallel to the y-axis, it won't have a y-intercept. Down here, we are doing some linear combination or substitution that you learned in Algebra 1. So finding the intersection of the two lines, you are solving them simultaneously to find an x and y combination that will make this equation true and this equation true. It has to be the same x and y's. And some of you could even figure this one out in your head. What are two numbers that add to be 6 but also subtract to be 2? But if you can't do that, you could also use linear combination substitution. So work through that, push pause, come back. All right, what I did here was linear combination. If you add down the columns, remember, this is also called elimination method, I think, in some places. X plus x is 2x. Y plus negative y gives me no y's. And 6 plus 2 is 8. Solve that. I get x equals 4. And then I say, okay, well, what is y if x equals 4? So I plugged in 4 into the top equation and solve for y, which is 2. And you can check that. 4 plus 2 is 6, and 4 minus 2 is 2. So this is the one point that will make both equations true. All right, this one's a little more difficult, but you've done it before. So give it a try and then come back. So please push pause now. All right, again here, I was looking for to cancel one of the variables. I chose y. It doesn't really matter. So I multiplied the top equation, everything by 2, the bottom equation, everything by -3, with the goal of having a positive 6 and a negative 6. When I add those down the columns, again, the y's cancel. I get 4x equals 12, so x equals 3. I plugged in 3 for x, and I solved for y, and I got y equals 2. So 3, 2, that gives me 15 plus 6, which is 21, and 6 plus 4, which is 10, and that is the solution to that equation. So if you have any questions, please write those down, and that concludes 13.6.